Welcome everybody, and thanks for joining us for the Gas Heater Safety webinar. My name's Brendan Gould from the Master Plumbers, and I'll be your host for this evening. Before we get started, Marnie Williams, the Director of Energy Safety with Energy Safe Victoria, would like to say a few words.
Hi, my name is Marnie Williams and I'm the new Director of Energy Safety here at Energy Safe Victoria. I, like many other Victorians, find myself unexpectedly working from home in recent times and unfortunately unable to see you all in person. I did, however, want to welcome you to this pre-winter carbon monoxide seminar series. I understand we've been running these sessions with the Master Plumbers across the state since 2011, and this year, due to the COVID-19 pandemic, we are for the very first time using a webinar format. So I do hope you find the technology accessible, and we will be looking forward to getting your feedback. Given the current lockdown restrictions, there will be many families confined to home as winter approaches, reliant on the safe operation of their gas appliances. As gas fitters, you all have a critical role in providing that assurance to Victorians, and this year to do so in a way that keeps both you and others safe from the spread of COVID-19. So to assist you in carrying out this important role, Energy Safe Victoria and the Victorian Building Authority have compiled a suite of information we're calling the Type A Gas Fitters Toolbox, which will be available on both our websites after this session. I do hope you find the information in the session of value, and please stay safe.
So just to go over a couple of the topics that we'll be covering off tonight. We'll be looking at the suite of online resources that have been made available, how to calculate the safe carbon monoxide working levels, Type A gas appliance servicing requirements, and how to conduct a negative pressure test and a carbon monoxide spillage test. To assist with any questions that you may have regarding tonight's webinar, we have an expert panel of representatives from both ESV and the VBA that will be able to answer your questions. If you just click onto the Q&A icon at the bottom of your screen on your toolbar, you'll be able to type in your question and the guys will hopefully answer your questions throughout the evening. We will also have a live Q&A session at the end of the program where we will look at the topics of the night and answer those questions as we go through. If anybody doesn't have their question answered tonight throughout the webinar, we will get back to you directly via email. So firstly, what we're going to do is we're going to have a look at the Type A Appliance Gas Fitter Toolkit that's been developed by ESV and as mentioned in Marnie's opening address. So this web page has been developed that sits on ESV's website to assist plumbers and gas fitters out there that are doing work during this time. So if we have a bit of a look at the website here and the web page, what we can see is there's some updated advisories around face coverings that are now mandatory when we're out there working within the public. So please make sure that if you are entering people's homes that you do follow the appropriate guidelines and have a face mask available to ensure everybody's safety. The web page itself goes into detail in relation to how we can protect ourselves and others during this time of COVID and in relation to making sure that while you're carrying out your work and for anybody that you might be doing the work for, will continue to be safe. There's also some additional information regarding opportunities that you can use if for some reason you are asked to go into a premises where someone has actually tested positive for COVID or they are a close contact of someone who has tested positive for COVID as well. There's just additional information and precautions around what you should be able to do there just to make sure that again that you are safe and consumers are also safe during the activities that you are undertaking. The web page also has a lot of good information that has been developed by ESV and the VBA in relation to the guidance material. There's a lot of the gas information sheets that we will be looking at tonight throughout the webinar that are listed on this website and the web page, and I advise everybody to become familiar with the web page itself just so you can assist you in keeping up to date with all the information. There's also the animation relating to negative pressure, also information about the frequently asked questions from the series of webinars that we've been undertaking throughout this year, and also some information regarding the negative pressure letter that has been co-developed between ESV and VBA. So there's a lot of good information on the web page itself, and again, like I say, it's advisable that everyone becomes familiar with the information that's sitting on the web page. So as mentioned, it's really important for people that are undertaking Type A appliance servicing work that they are aware of the risks regarding exposure to CO. Now we're learning more and more about carbon monoxide as we go through time, and in relation to incidences that may have occurred over people's experience with servicing appliances. So we do understand that there are limitations regarding exposure to carbon monoxide, and we also need to be aware of the equipment that we're using when we're undertaking these tests. So firstly, what we'll do is we'll have a look at Gas Information Sheet 37, which talks about carbon monoxide measuring equipment. So as you see here, there's some information around what we're looking for when we're looking at carbon monoxide detecting equipment. So a couple of things that we need to be aware of. The range of measurement needs to be between 0 and 1,000 parts per million. We need to ensure that the carbon monoxide detector has the ability to measure low levels of increments, low levels at 1 part per million or smaller. The detector needs to have a CO measurement with a precision of plus or minus 5%, and it also needs to have a low battery indicator. A couple of other things that are nice to have in relation to your detector: a manually zeroing function and an audible alarm. It's also important when we understand our equipment that we're using, that if you're using a handheld type device, that you do not place it in front of the heater's discharge airstream, as it may overheat the CO detector itself. There have been findings where carbon monoxide detectors that have been placed in the heat stream of an appliance have given a false reading of a higher level of carbon monoxide than it actually is present. So please be mindful of the manufacturer's operating instructions and make sure that you are using your detector as per the instructions of the manufacturer. If you are using a probe type detector, you can get the probe much closer to the heat source than you can for a handheld detector. It's also really important to understand the calibration of the equipment. So when you are carrying out Type A appliance servicing work, you do need to have your carbon monoxide detecting equipment calibrated every 12 months so that it is calibrated by a NATA laboratory to ensure that the certificate is there for the currency of the test, to make sure that if for any reason the appliance is called in question, you can show that it has been calibrated within the last 12 months. So that's good information there in relation to what we need to be looking for in relation to carbon monoxide detectors. So when we're looking at the safe working levels of carbon monoxide, it's important that we understand that Safe Work Australia has a time-weighted average of 30 parts per million of exposure over an 8-hour day. So it's important that we understand what that exposure may look like. So a couple of examples of exposure that we need to be mindful of on this table here will tell us that if we have a concentration level of 200 parts per million of carbon monoxide, we should not be exposed to that level for more than 15 minutes. If it's 100 parts per million, the time frame should be no longer than 30 minutes, and at 60 parts per million, no longer than 60 minutes. It's also important to note that there should be no excursion over 400 parts per million. We do understand that in some of the situations that we've seen in Victoria since 2010, where the carbon monoxide level was greater than 1,000 parts per million, and we understand that in situations like that, quite often that can be fatal. So it's really important that we understand what we're talking about with our time-weighted average and how that's developed. Now that's 30 parts per million over an 8-hour day. What we'll do is we'll have a look at a couple of examples of what that might look like. So in this example here, what we do, we see we have a Type A appliance technician going in to do some service work on an appliance. Within that appliance, there's been spillage at the draft diverter was 400 parts per million, but the gas fitter was exposed to 90 parts per million for a period of 20 minutes. Now what we do to calculate the time-weighted average for that excursion is we multiply the exposure of 90 parts per million by the time frame that the technician was exposed, which is 20 minutes, and then we divide that by the minutes in an 8-hour day, which is 480 minutes. So when we look here, we have a figure of 1800 divided by 480, which leaves us with a figure of 3.75 parts per million for an 8-hour period. So that time-weighted average of 3.75 is well below the 30 that's recommended by Safe Work Australia. So in a situation like this, if you were doing one service in the day and you were limited to 90 parts per million of exposure for that 20-minute period, you are in no harm of the carbon monoxide exposure. If we have a look at a different example where we see someone who has had multiple excursions because they've been doing service work on multiple appliances, we see that there's been 6 jobs. All of the jobs have a different exposure to carbon monoxide, and they've all been exposed for a different period of time. So the way that we calculate that is we look at each exposure individually and we add them all up. So we've got 90 by 30, 85 by 35, 100 by 25, 180 by 15, 110 by 27 and 45 by 32 to give us a total of 15,285. So again, what we do is we divide that by the minutes in the day of the 8-hour day is 480, and that gets us to a level of 31.8 parts per million. Now, what we see here is we see a level which is greater than the 30 parts per million advised by Safe Work Australia. So if you are doing work like this, what we would advise you to do is you're calculating your time weighted average for each of the jobs that you do. And in a situation like this, advice would be that you wouldn't go to job 6. What you would need to do is effectively not go and do job 6, so you're keeping yourself under that time weighted average of 30 parts per million. But there is an example of what you can do to calculate your time weighted average for multiple excursions. So the next thing we're going to look at is our obligations under the Gas Safety Act. So the Gas Safety Act of 1997 suggests that a person carrying out gas fitting work on an appliance or a gas installation must ensure that that appliance or gas installation complies with the prescribed standards and requirements in relation to that appliance or gas installation. Also, the Gas Safety Installation Regulations 2018 state that the gas installation not be made unsafe during the gas fitting work, and the gas installation is safe for use on completion of the gas fitting work. So what does that look like when we're talking about Type A appliances and carbon monoxide spillage? An example would be that if you were looking at a gas installation and there was a gas escape on that line, you would know straight away that that is an unsafe situation, and that situation would need to be rectified and couldn't be left. What we understand when we're looking at carbon monoxide spillage is if you have a Type A appliance that might be in a negative pressure environment, but the appliance itself is not spilling carbon monoxide, that is not deemed an unsafe environment at that particular stage, because the appliance itself is not spilling carbon monoxide. There is no doubt that the negative pressure needs to be addressed, and a ventilation system will need to be put in place to make sure that that negative pressure can be overcome. But due to the fact that the appliance itself is not spilling CO, that situation isn't deemed to be an unsafe situation. So it's really important that we understand what that means for us when we're going out to do that work, and that is why the ESV and the VBA have put some things together for us to help us out when we're doing that work out in the community. So what does that mean for us as gas fitters and people that are doing work? Ensuring a gas installation is safe is the fundamental responsibility of all gas fitters licensed to perform gas servicing on Type A appliances. And as a result, understanding the required scope of work is critical for gas fitters to be able to complete it successfully and meet their responsibilities under the Gas Safety Act and any other subordinate regulation. So we need to make sure that we understand what the regulations mean in relation to how we are registered with the VBA and the endorsements that we hold. So plumbers holding registration or licence in gas fitting can install and commission Type A appliances. And as part of that the commissioning process, Appendix R of the AS 5601 suggests that we do need to do a negative pressure test and a carbon monoxide spillage test when we commission any appliance. So under our obligations under the Gas Safety Act, we need to ensure that we are doing those two things as part of that commission. When we look at Type A appliance servicing, only plumbers holding registration or licence in the specialised class of Type A appliance servicing are permitted to do service work. So if you do not hold the endorsement of Type A appliance servicing, you are not able to do carbon monoxide spillage tests on already installed appliances. That is specifically plumbing work. What that means for us, under Part 5 of the plumbing regulations, what servicing is, Type A appliance servicing work is the internal cleaning, maintenance and adjusting of a Type A appliance, and includes the adjustment, repair or replacement of a component of that Type A appliance. So it's really important to understand that for employers of plumbers that may have come through the training system after 2008, they may not hold the specialised endorsement of Type A appliance servicing. So it's important that you do understand that if you want to be doing Type A appliance servicing work, you do need to hold the endorsement on your registration or licence. And for people that came out through the training system or the apprenticeship system after 2008, there is a very high chance that they would not hold that Type A appliance endorsement unless they have undertaken further training. We do offer the training here at Master Plumbers, so feel free to contact us and we can let you know what the situation is. So moving on in relation to what we're looking for now, which is the adequate air supply for appliances. So there's a couple of things here that we're going to look at: air supply quality to the appliances, air supply adequacy for the appliances, and the adverse effect of air movement systems. So we're going to have a look here at gas information sheet 58. So gas information sheet 58 tells us about what we need to look for when we're talking about the quality and adequacy of air supply to the appliances, and it's drawing from information out of the ASNZ 5601. So when we're talking about air supply quality, it's important to understand that what we're looking for here is that air supply should not be contaminated. We want to make sure that there's no chemicals, dust fibres or flammable vapours that are actually using to support the burning of any natural gas flame. It's also really important to understand here that there has been some changes in relation to our calculations for ventilations and the requirement for ventilations when we're looking at the amount of air needed to ensure that a Type A appliance is operating correctly. So when we have buildings approved before the 31st of March 2014, and we have buildings approved on or after the 31st of March 2014. Now what we need to understand here is in clause 6.4.4 of the ASNZ 5601, we have a allocation of 3 megajoules per hour per cubic metre in relation to an appliance to ensure that the room is big enough that there is enough ventilation for that, or enough air for that appliance to operate correctly. So an example here would be for an appliance that is drawing 30 megajoules per hour to operate, that if the room was smaller than 10 cubic metres, we would need additional ventilation. So that's allowing 3 megajoules per hour per cubic metre for air to make sure that that appliance is going to operate correctly. If we have a look at the example where we have buildings approved on or after the 31st of March 2014, ASNZ 5601 clause 6.4.5, there's a change. So we're looking at now we only have an allowance of 0.4 megajoules per hour per cubic metre. So what that means is if you have an appliance that's been installed with a rating of 30 megajoules per hour that you'll find on the compliance plate, that if the room is smaller than 75 cubic metres, you will need to install additional ventilation. So there is some information on ESV's Type A gas fitter toolkit around how you can calculate that ventilation process. So it's really important that you understand that there have been changes. The changes for buildings that have been approved on or after the 31st of March 2014, and the fact that we have a reduced rate of megajoules per hour per cubic metre is due to the fact that we don't have anywhere near as much adventitious air as we had in buildings prior. Because what we've done when we're looking for higher ratings for insulation, we're effectively closing up the doors and the window frames, and we're just not getting as much air into the space to help assist with that natural Type A appliance working correctly. So again, gas information sheet 38 also tells us about air supply adequacy to the appliance itself, and also the adverse effect of air movement systems. So this is a situation where what we're looking for here is that if we do bring in any mechanical ventilation, so we have Type A appliances, open flute appliances that are installed where there may be exhaust fans in the property, there may be range hoods in the property, we need to be aware of what that may do to the workings of the appliance itself. And what we need to understand is if we do have a situation where any of these exhaust fans may cause negative pressure, we need to work out how we can overcome that negative pressure. So when we're looking about servicing appliances, it's really important that we understand that it's not just a case of going and maybe vacuum the appliance or just giving it a bit of a clean down. What we would like to see, and ESV would like to see, is more of a thorough service of that appliance, understanding there's quite a few things that we need to look for. Some of the things we want to look at is making sure that the appliance is inspected, the installation is inspected itself before we complete that thorough service of the appliance. Now, gas information sheet 59 will give us some guidelines as to what ESV are looking for in that regard. So if we have a look at the inspection checklist, a few things that we'd like you to look for. Having a look to see if the flue and the cowl is in good condition, looking to see if there is adequate ventilation, as suggested in information sheet 58. Is the appliance installed correctly? Is the appliance in good condition? So looking for things like burn or scorch marks on the appliance, and of course there are indications that potentially there's been some overheating and maybe something's not quite as it should be. Also, at this inspection point, we can conduct a negative pressure test or the smoke test to ensure that if there is any negative pressure, that we can have a look at how we can alleviate that negative pressure. So when we're getting a look at the service of the appliance itself, things that we would like to see are the cleaning of the fan, making sure that the pilot and the main burner have been cleaned, ensuring that all dust has been removed from the appliance itself, checking the operation of the safety switches, including the thermocouples and the thermostat, check the heat exchanger for any metal fatigue, checking that the back wall of an inbuilt wall furnace for signs of heat stress. If heat stress is present, further examination of the fan and the heat exchanger is certainly warranted. Conducting a visual test of all parts and replace them if they're showing signs of fatigue or heat damage. Also to check if any necessarily resets in relation to the appliance's operating pressure. We need to make sure that the appliance is operating at the pressure as indicated on the compliance plate before we can do the carbon monoxide spillage test. So what we want to do is make sure that the appliance itself is installed correctly, it's in good working order, so that we can undertake the tests that we need to do for carbon monoxide spillage. And by doing all these things, the consumer should be satisfied that the heater itself or the appliance is going to work properly, and then you also should be satisfied that you've done everything that you can do to make sure that the appliance is going to work well. So what we're going to do now is we're going to have a look at the negative pressure animation that has been developed by ESV to just give us a good indication of what we should be looking for when we're talking about how negative pressure can affect open flued gas appliances.
The safe operation of any gas appliance requires an adequate air supply to the appliance. The safe operation of an open flue gas heater can be compromised by a negative pressure environment. This video explains what negative pressure is and its effect on gas appliances. AS NZS 5601 Part 1 2013 Clause 6.4.1. Adequacy of air supply states that gas appliances shall be installed in locations with adequate ventilation for complete combustion of gas, proper operation of the flue, and to maintain the temperature of the immediate surroundings at safe limits under normal operating conditions. This diagram shows the correct operation of open flue heaters. The arrows show how air is drawn into the appliance from the room for combustion. The products of combustion exit via the flue and into the atmosphere. If there is insufficient ventilation in the room or building, the installation is non-compliant and additional ventilation is required. Refer AS NZS 5601 Part 1 2013 Clause 6.3.1. Adverse effective air movement systems states, gas appliances shall not be installed where the operation of any ventilation system, air distribution system, fan, or air blower could, under any circumstances, A. Deprive the gas appliance of the air required for combustion and draft diverter dilution, or B. Otherwise adversely affect the operation of the gas appliance. A negative pressure environment can be created within the room or building when exhaust fans are turned on, if there is inadequate permanent ventilation. In an attempt to equalize the pressure in the room, air is drawn into the building from external openings. In an open flue heater, the flue can operate as an opening to relieve the negative pressure. To prevent this from happening, install ventilation in the room to equalize the air pressure. This will enable the appliance to operate safely. To achieve the greatest negative pressure effect, close external doors and windows in the building. Then, open or close internal doors to create the maximum potential negative pressure. Switch on all extraction fans. Now carry out a smoke test. A smoke test must be carried out when your gas appliance is off and the flue is cold. Using a smoke match, check that smoke is not drawn away from the appliance draft diverter relief openings or from the appliance combustion air intake. If smoke is drawn away from the appliance, slowly open a window in the room where the appliance is installed to equalize the air pressure. The open window will act as a guide to how much additional fixed ventilation is required. When the smoke is drawn towards the downdraft diverter opening, the heater in general, or straight up towards the ceiling, then the gap in the window opening is providing sufficient ventilation to overcome the effects of the negative pressure caused by the extraction fans. The size of the window opening is an indication of the fixed ventilation required to be installed. Please be mindful that on windy days you may see intermittent disturbances of smokes at the downdraft diverter from wind gusts at the flue cowl. This is not a sign of negative pressure. Negative pressure will draw a constant stream of smoke away from the heater. It's time to conduct a CO spillage test once you have established your installation has sufficient air supply for combustion and that extraction fans are not having an adverse effect on the operation of the appliance.
So just to recap in relation to what we want to see, what we've seen there in relation to the negative pressure test, if we do have a situation where you have an open flute appliance and there is negative pressure present, you do need to make sure that you can work out the size of the ventilation that's required to overcome that negative pressure, and that is done by opening a window slowly, calculating the opening of that window, ensuring that you allow for the free ventilation, so that opening may not be the same size of the vent that's required, because we need to understand that if we're putting in a grill, the vent will be a little bit bigger than that, because we need to understand that the opening is fixed free ventilation. Once we've been able to establish what we need in relation to fixed free ventilation, that ventilation will need to be installed. It's important that we understand that before we do that negative pressure test though, and one of the things that's been understood a little bit more about carbon monoxide spillage and when plumbers are out doing the work, is that we do need to understand what it might be for the baseline condition so that we have a point of reference when we are doing our negative pressure test. So if we're looking at our negative pressure test and the baseline condition test, what we see is gas information 38 can take us through the steps that we need that are required to adequately understand those provisions. So when we're looking at establishing the baseline conditions, a couple of things that we need to remember. That we do need to ensure that the gas heater is switched off and that the flue is cold. We do close all external doors and windows, ensure all extraction fans are switched off. Then what we do is we position a suitable smoke producing device at the appliance draft diverter relief opening or next to the appliance opening for combustion air. What we do then is we have a look at what will happen with the smoke. Now, depending on the atmospheric conditions of the day, you might find that the smoke may flutter, you might find that the smoke might go straight up, depending on what's happening. Now, what we need you to understand here is we're looking again for a point of reference so that when you do turn on the exhaust fans and you're looking at whether or not there is a negative pressure in the room itself, you have a point of reference to make that judgment call. So once you've established your baseline condition and you write that down, note that down as to what that may be, you can then move on to the negative pressure test. So when we're doing our negative pressure test, again what we're looking for is that we're ensuring that the gas heater is switched off and the flue is cold. We're ensuring that all external doors and windows are still closed. Ensure that the extraction fans are operating. What we do then is we open any internal door which may be leading to an exhaust fan from that appliance. Because what we want to do is we want to disadvantage the appliance as much as possible. So that means if you have an exhaust fan in a bathroom or a laundry, you would open up the laundry door or the bathroom door. If you have a range hood in the kitchen and it's not an open planned environment, you need to open up the kitchen door as well. What we advise is that you leave those fans running for 5 to 10 minutes to see if you can create that negative pressure before operating your smoke test. So after that 10 to 15 minute period, what you then can do is use your smoking device, again holding it near the draft diverter or the appliance's combustion air intake, and see what happens. So what we would like to see in the best case scenario, of course, is that smoke would operate the same way as you did for your baseline test. If for some reason the smoke is drawn towards the exhaust fans, then what we know there is that we do have a negative pressure. And that's when we need to make sure that, again, we go through that process of opening up windows slowly to ensure that we can overcome that negative pressure. Once we've satisfied that we've overcome the negative pressure and we've calculated the openings for the ventilation or the requirement for the ventilation, we can then move on to the carbon monoxide spillage test. So at that point, we then need to shut that window, again, because when we're doing the carbon monoxide spillage test, we do want to make sure that the appliance itself is at its most disadvantaged. So when we're testing for carbon monoxide spillage, we close any window that we opened as suggested for the negative pressure environment test. we turn on our carbon monoxide detecting equipment, take some background readings to ensure that if there is carbon monoxide present, we understand that it might be there. You may get carbon monoxide present due to potentially someone who may have been cooking in the space fairly recently. It could be that there's a road close by where there's a lot of traffic and there may be carbon monoxide in the space again. So one of the things we need to do is we do some background readings and note down what that background reading is. If you have that ability to then reset your detector, you can certainly then reset that detector. Again, we're ensuring that at this point in time that all extraction fans are still operating. What we then do is we turn on the appliance itself and we turn it on to the highest setting, and if there is a fan available, we turn it on to its highest setting as well. So when we're undertaking our carbon monoxide spillage test, what we need to do is ensure that the appliance is able to operate and it's able to heat up. Okay, so what we need to, and we understand that with a natural draft flue, that the appliance itself and the flueway will take a little bit of time to heat up before it can draw properly. So that allows us to see what is happening in relation to the negative pressure. You will have appliances that may produce small amounts of carbon monoxide at the draft diverter while the appliance is still heating up. So that's why we don't want to take the reading straight away. So after a period of 5 minutes, what we can then do is we place our carbon monoxide detecting equipment at the downdraft diverter relief opening, and we can take some samples. We also need to check heat exchanger joints, the warm air outlet if it's a ducted heater, flue connections, and the base of any flue product collection hood. So we're monitoring for CO spillage and record the readings taken after the appliance has been operating for a period of 5 minutes, or for 10 minutes from cold if it's a type 1 decorative effect gas heater. And again, like I say, the reason why we wait 5 minutes or 10 minutes is to allow us to understand or give us some time for those flueways to warm up. So after a period of 5 minutes or 10 minutes, depending on the appliance that you are doing a carbon monoxide spillage test, what we don't want to see is any rise above the base level finding. If there is a rise above the base level finding, that's when you may need to do an investigation to find out whether or not the CO spillage can be rectified. So when we're looking at assessing carbon monoxide test outcomes, if there is no carbon monoxide spillage detected, but there is a negative pressure in the space, what we then need to do is inform the consumer that fixed ventilation will need to be installed to overcome that negative pressure. As a temporary measure, a window could be left open in the room while the appliance is operating, and extraction fans that are located should be switched off while the heater is operating. And this is where we need to use the letter that's been co-branded by ESV and the VBA to inform the consumer about that situation. What we need to do as the plumber in that situation is inform the VBA that there is a situation of negative pressure and an open fluid appliance, but it is not spilling CO, on the emailing address of gasheaters@vba.vic.gov.au or by calling the 1300 815 127 number. Now what will happen there is the VBA will take carriage of that example and they will make contact with the homeowner to ensure that fixed ventilation is installed in that situation. That situation is not necessarily a situation that ESV have any control over specifically, and that is why it is up to the VBA in relation to contacting the consumer at that point of time. When we're looking at a situation where carbon monoxide spillage has been detected, then what we need to do is work out what is the reason for that carbon monoxide spillage. Now, what we need to do is if we have detected carbon monoxide spillage, what we need to do is switch off the extraction fans and operate the appliance at its highest level with the burner and the fan operating. So again, what we're going to do is we're going to wait for 5 minutes and we're going to test again for carbon monoxide spillage. Now, if we don't have carbon monoxide spillage at that point in time, what we then need to do is turn the exhaust fans on again to see whether or not that might be the reason for the carbon monoxide spillage. So what we were doing is by level of deduction, we're going to find out whether or not it's the negative pressure that's causing the spillage of carbon monoxide for the appliance, or whether or not it is that there's a fault with the appliance itself. Now, if there's a fault with the appliance, that fault may be rectified. And that could be the situation where the unit itself just needs to have replacement done, or in a situation where the appliance itself is spilling CO without negative pressure, it might be a situation, if the appliance has gone through its full life cycle, that it may need to be replaced. So what we need to do is understand what the situation is around the carbon monoxide spillage, why it's spilling, and how we might deduce if it's carbon monoxide that's spilling due to negative pressure, or it's because the appliance itself is faulting. So again, just to recap, what we're looking for is we're looking at we don't want to exceed the background levels of our carbon monoxide readings adjacent to the draft diverter or the air discharge point of any open fluid appliance after a period of 5 minutes, or a period of 10 minutes if it's a type 1 decorative flame effect fire installed in a chimney. So again, just to recap in relation to corrective action, if there is a situation where carbon monoxide spillage has been detected, you need to investigate the possible causes, again to see whether or not it is due to negative pressure or a fault with the appliance. You do need to be careful and systematic when you're going through this process. If you can, correct any installation fault or potentially complete a new installation. If you are unable to correct the fault, or you are in a position where the installation cannot be installed at that point in time, the appliance must be isolated until it has been rectified. Now, in relation to ESV, if for some reason the homeowner will not allow you to isolate that appliance, ESV's 24/7 hotline, 1800 652 563, and by selecting option 5, you can leave the details of the installation on that hotline itself. ESV will be in contact with you, the plumber. They will also then probably contact the consumer to let them know what needs to happen. You certainly aren't in a position where you may have a carbon monoxide spillage of an appliance. You are certainly not allowed to disconnect the effectively damage the appliance by cutting a thermocouple lead or effectively cutting a power cord. In that situation, it's unlawful damage, so please don't do that. Please contact ESV on the hotline number and they will take carriage of that situation. And then what you have done is you have successfully done everything you can do under the Gas Safety Act. So as part of ESV's suite of information that they're providing for practitioners that are working in the Type A appliance field, on the Type A Gas Fitter Toolkit webpage, there is some sheets and some test reports that you can download and use. Just a couple of examples of this is the carbon monoxide spillage test report. This allows you to put information about the client address, client name, what you might have found when you've been undertaking the baseline condition test, negative pressure test, when you've tested for carbon monoxide spillage, and all the information that you've had in relation to those tests can be effectively inputted into the sheet itself. That sheet then can be kept for your own records and also passed on to the consumer. With the carbon monoxide spillage test report, there's also information here for the ESV hotline in relation to 1800 652 563 and option 5 to allow ESV to take carriage of any situation where you may have carbon monoxide spillage, but you do not have permission from the owner to isolate the appliance. A recent addition to ESV's suite of information is the Gas Heater Type A Appliance Service Report. Again, the report has been developed with practitioners in mind, freely available. You certainly can download it. You can use the information to produce your own templates under your own logos. Again, it's just information that ESV believes is really important, that you have information about the appliance itself and the service that you've conducted, plus information that you can leave with the consumer so that there's a historical list and sort of recognition of what the appliance has been put through while it's been serviced, and if there's been any information about changes of any of the components of the appliance over the period of its lifespan. Again, information sheets are freely available and downloadable from the ESV Gas Fitter Type A Toolkit on their website. As an initiative from Master Plumbers, we also have some gas appliance service report kits available. We do sell these. One of the reasons we sell them is because any profit that we make, we effectively pass on to the Chase and Tyler Foundation in relation to assisting them with the process of getting information about carbon monoxide out to the community. That certainly helps us in relation to making sure that people are fully aware that appliances should be serviced at least every 2 years. There are some situations where manufacturers would ask for appliances to be serviced more readily than that, but as a minimum, ESV, VBA and Master Plumbers would like to see all appliances tested at least every 2 years. And as part of the Chase and Tyler Foundations, what they are trying to do is get that information out into the general public so the consumers are more aware of what they should be doing in relation to appliance safety. As part of our appliance servicing pack, we also have some stickers that come as part of that pack. that allows us to stick them onto the electrical meter box, which will indicate to an electrician if they're doing any work, which may be to install additional exhaust fans or potentially changeovers for things like range hoods, that there is a Type A appliance that has an open flue, which is installed in the premises. And if they do install any new electrical equipment that might adversely affect that appliance, for the consumer to contact a plumber to get that installation tested. The letter that is available for ESV and VBA effectively for situations where you may have an appliance that is not spilling carbon monoxide but there's a negative pressure present. This letter is available again on both ESV and the VBA website. It's sitting on ESV's Type A Gas Fitter Toolkit page. Information that can be passed on to the consumer where you do have a situation of an appliance that's in a negative pressure environment but it's not spilling carbon monoxide. This letter will explain to the consumer the dangers of carbon monoxide, what needs to be done in relation to fixing that negative pressure situation, and what you might need to do to use that open flue appliance prior to any fixed ventilation being installed. Now, as part of this, what we'd like you to do is contact the VBA before passing this letter over to ensure that the VBA again can take carriage of this situation. What they will do is if for some reason you are unable to install that ventilation, they will follow up with the homeowner to ensure that that ventilation has been installed. ESV also have a series of alerts on different appliances. These appliances have been effectively retested under circumstances to ensure that they aren't spilling CO. Unfortunately, some of the appliances did spill some CO in some situations. So what has happened is that the manufacturers have been asked to come up with a rectification. The appliances, apart from the Vulcan Pyrex Heritage and the Canon Fitzroy and Canterbury, all the other appliances here can be fixed if they are installed. If you do come across any of the appliances, please do look for the sticker on the appliance itself, which will indicate that it has been rectified. If it has not been rectified, before you do the service, you'll need to contact the manufacturer. You can get a kit that allows you to rectify that appliance so it will not spill, and then you can undertake the service. With the Vulcan Pyrex Heritage or the Canon Fitzroy and Canterbury, there is a deed of understanding with that manufacturer that if you come across one of these appliances, please contact the manufacturer. The manufacturer will be in touch with the homeowner to make arrangements for that heater to be effectively removed and replaced. So that brings us back to the end of the sort of formal proceedings of the webinar. What we will do is we're going to just hear from Alison Byrne. Alison is the Executive Director of Operations with the VBA, and she is going to recap what we've done tonight before we open the Q&A session. Once Alison has completed, what we will do is we will have a Q&A session from the ESV and VBA, and that Q&A session will be around effectively the information from this evening and any questions that you've sent through. What we'll do is we'll look at the topics of the night, so the most sort of popular topics of the night, and the guys will answer some of the questions. So thanks very much everyone for joining in with this for the webinar, and please stay safe. Thank you.
Hi, I'm Alison Byrne, Executive Director of Operations at the Victorian Building Authority. Thanks for your participation in this year's Gas Heater Safety Seminar presented by Master Plumbers on behalf of the Victorian Building Authority and Energy Safe Victoria. We've covered a lot of ground today. To help you carry out gas fitting work safely and competently, you'll find a range of resources in ESV's Type A Appliance Gas Fitter Toolkit. Available from the ESV website, the toolkit contains practical information on how you can reduce your risk of exposure to the coronavirus. The toolkit also outlines your legislative responsibilities and contains a number of resources developed jointly by the VBA and ESV, so your knowledge of installation and testing procedures remains up to date. Today, Master Plumbers reminded us just how important it is that you're aware of the risks of carbon monoxide exposure. Carbon monoxide is a silent killer. It's colourless, tasteless and odourless. That's why it's so important you make sure that your equipment is calibrated and fit for purpose when carrying out Type A appliance servicing work. Master Plumbers also provided a useful summary of your responsibilities under the Gas Safety Act and the Gas Safety Gas Installations Regulations. To recap briefly, Type A gas appliances must be safe for use when you have finished your work. During the presentation, we witnessed the impacts of negative pressure on open-flued gas appliances. We then learnt about the importance of the carbon monoxide spillage test and the key steps needed to carry it out correctly. More information on these important topics is available from the VBA and ESV websites. If you head online, you'll find useful resources such as checklists and service reports for both carbon monoxide spillage testing and Type A gas heater servicing. These resources are free for you to download and use. The VBA and ESV have also published a consumer advice letter that you can give to your clients if they refuse to allow you to make their gas appliance safe. So to wrap up, we hope you found the presentation useful. A recording of the webinar and our PowerPoint presentation will be made available on both the VBA and ESV websites. The VBA, ESV and Master Plumbers are committed to your ongoing learning and providing the knowledge you need to carry out your work. We hope to present more seminars like this in the future. As gas fitters, you play an essential role in keeping communities safe and healthy. Once again, thanks for attending this webinar. Take care and stay safe.